Hi, so today's going to be a bit longer of a video, and the things that we're covering are a little bit more advanced than some of my previous videos. That doesn't mean that they're impossible, I just think that it will take a little bit more time to explain. So, for this first example that we have, it's asking us a few things. The best thing to do, I always say this, the best thing to do when you have a new problem is to just read it. Read it to make sure that you know what is being asked of you. So it's saying, find the missing terms of the sequence and determine if the sequence is arithmetic, geometric, or neither. And then it gives a list of numbers. Here are some terms that you may or may not have heard before. We can go over them really quickly. So, hold on, give me just a second to change my font. So arithmetic. These are all talking about sequences of numbers, which means that there's more than one number, give or take. It's a little more complicated than that, but you'll get it. Arithmetic sequences are basically when you have a consistent addition or subtraction between two consecutive numbers. So if you add something like 3, 6, 9, 12. This would be arithmetic because you're adding 3 each time. We would know in our next number, it would probably be 15 because we are adding 3 each time. So let me get rid of that. Geometric is when you have a sequence of numbers that are being multiplied or divided by the same amount for each number in the sequence. So if we had something like 2, 4, 8, 16, 32, we would know that this is geometric because it's timesing by 2 each time. And we would know that the next number in the sequence would be 64 because 32 times 2 is 64. That is a geometric sequence. Now, there are sequences that are neither geometric or arithmetic. If you had something such as 1, 2, 4. Sorry, I have to think about this. Sorry, it's kind of hard to come up with them on the fly. 1, 4, 2, 5, 3, 6, ... We could see that, well, first we want to look for patterns in these equations. 1 to 4, that's plus 3. 4 to 2, that would be minus 2. So that doesn't really quite work for either because it's not a consistent change. However, it is a pattern. We can see that 1 to 2 is plus 1. 4 to 5 is plus 1. 2 to 3 is plus 1. And 5 to 6 is plus 1. 3 plus 1 should be 4. So we would assume that the next number in our sequence would be 4. However, because it has that inconsistent progression, it is neither geometric or arithmetic. So let's go back to this example problem that we have. 5 to 9, that is a plus 4 increase. 9 to 13 is also plus 4. 13 to 17 is also plus 4. We can assume that 17 to this next number is going to be 17 plus 4, which equals 21. We can assume that 21 to this next number is going to be plus 4, which is going to give us 25. It is adding consistently each time, so it's going to be arithmetic. Okay, so the next problem that we have doesn't have to do with sequences. But we will have another problem that does deal with sequences. I'm just doing a lot of example problems just so you can get an idea of how to do them. So reading this problem, it's asking us to find a counterexample to the statement, the sum of two different prime numbers is always prime. We can think of prime numbers. So prime numbers are numbers that only have 1 as its, 1 and itself as its, like the only factors that fit into it. So 3 is a prime number because 1, if nothing else except for 1 and 3 go into 3 when you're multiplying, when it comes to whole numbers. 5 is also a whole number, but when you add 3 and 5 together, that gives us 8. And 8 is divisible by 2 and 4. So 8 is not a prime number. 5 plus 3 are prime numbers. They do not equal a prime number when you add them. So that would be a good example for that problem. Here's another sequence problem. We have patterns that I can see things that come out to my eye immediately is from 64 to 32. We are dividing by 2. I'm going to do 256 divided by 128 to see if that will equal 2. 256 divided by 128 is equal to 2, so that works. And then if we do 128 divided by 2, we should get 64. So with that logic, we can think that 62 divided by 2 is going to equal 16. 16 divided by 2 is equal to 8. So the next numbers in our sequence would be 16, 8. And because it is dividing, that's an 8, dividing consistently by 2 each time, it's going to be geometric. Here's one that is sort of a different vein. It's asking us to consider the following pattern and to predict the results of 1, 1, 1, 1, 1, 1, diamond 16. So some patterns that we can see is 1, diamond 16 is equal to 16. Some things that kind of come to my mind at first is that 1 times 16 is 16. What happens if we times 11 by 16? Well, we get 176. So I kind of think that it's safe to assume that each time we add a 1, this diamond basically represents a multiplication sign. I don't know if it will always be like that in the examples that you're given, but for this problem it is. So 1, 1, 1, 1, 1, 1 times 16 is equal to 777,776. That would be our answer for this problem. The next problem that we're going to deal with regards deductive reasoning. So there's 2 key terms to think of when we hear the term deductive reasoning. There's deductive and there's inductive. It's maybe a little bit hard to think of at first, to grasp and to get the hang of. But deductive basically comes down to when you make an assumption based on something general. So you go from general to something specific. For example, you could say something like, the cupcake shop always has discounts on Wednesdays. Therefore, this Wednesday, the cupcake shop should have a discount. We are taking a specific example we're making a claim about a specific example this Wednesday based on a general assumption that the cupcake store has discounts on Wednesdays. The other term is inductive. Inductive reasoning is basically when you go from specific to general. So to stay with our cupcake example, inductive reasoning would say, this Wednesday, the cupcake store had a sale. Therefore, every Wednesday, the cupcake store has sales. This might not be true because it could just be that one day that they're like, oh, we have excess product or something, or oh, it's a holiday or something. Typically, it feels like deductive reasoning is a little bit more stable. However, the thing that you do need to keep note of is that basically deductive goes from general to specific, and inductive goes from specific to general. I don't know if there's a really easy way to think about that, to memorize that, but you will need to know that. So this question is asking for an example of deductive reasoning. Let's read these. So, this July, a nearby gym is offering free classes to college students, so it is likely that they will also offer this promotion every July in the future. This feels like inductive reasoning because we are taking a specific, this July they are offering free classes, and taking it to a general. Every July they will offer free classes because of this July. This would be inductive. This is not what we want. The second one says, For the past 2 weeks, a local florist had a sale on roses on Friday. So that florist should have roses on sale every Friday. This is also inductive because it is saying for the past 2 weeks. The past 2 weeks, not all weeks, and it's not a rule that we've seen. It's just the past 2 weeks. It's going from a specific to general every Friday. Sale every Friday. Kara should make 30 out of 75 free throws in the next 5 games since she made 6 out of 15 free throws in the first game. We're taking a specific since she made 16 out of 15 free throws in the first game. That's a specific. And we're going to a general. The general claim being she should make 30 out of 75 free throws. This is also inductive. The drive to work usually takes 30 minutes every day. If I leave my house today at 7:20 and have to be there by 8 o'clock, I should make it to work on time. This is deductive because we are taking a general. The drive to work usually takes 30 minutes each day, and making a claim about the specific. If I leave my house today at 7:20 and have to be to work by 8, I should make it to work on time. That would be deductive, and that would be the answer to our problem. The next question that we have is talking about reading graphs and making equations based on a graph. So this question it says, Luis has decided to start doing crunches as part of his daily exercise routine and is using the bar chart below to help keep track of how many he has done each day. How many crunches will he do on day 14? So, one thing to always look at when you're given questions like these is to look at where we start. Some questions in Hawks will start at something like 6 or 8 even. I don't know. It doesn't always start at 0, but it's important to know where it does start. We know that on the first day, he already has done 1 crunch. We know that each day, he does 3 more crunches than the last day. Some of the questions will ask you to make an equation for this. Now, let's test a few equations. It seems like if we did, let's say x equals days, and he does 3 crunches depending on how many days, like 3 times the amount of days. However, if we try this, on day 1, it doesn't really work out, because he, 3 times 1 equals 3. On day 2, it doesn't really work out because 3 times 2 is equal to 6. And he has only done 4. And so on. This doesn't really work out that well. One thing that we can think about is what would it look like on day 0? We know that he increases each day by 3. So going backwards, he should decrease each day by 3. He should decrease by 3 as well. So 1, 2, 3. On day 0, he would start on -2 crunches. Now, this isn't really possible in real life, but when we're thinking about patterns, and making an equation for the pattern, we want to find out how many he would do on day 0, even if it's not technically possible, so we are able to calculate the rest. It's basically our starting point. So let's try this. 3x minus 2. That works for 1, because 3 times 1 equals 3, minus 2 equals 1, so he's done 1. 3 times 3 is equal to 9, minus 2 is equal to 7, which checks out with this as well. So this would be our equation. Now, having that equation, we can plug in 14 for x. So 3 times 14, and let me just do that because I don't have that off the top of my head, is 42, and then minus 2 is equal to 40. So he does 40 crunches on day 14. One other thing to note is when you're in Hawks, sometimes it says this is this is every 2, so it's go to 4. Like, you just want to keep track of your axes and see how that might work out. Here is another sequence problem. This one goes from 1701 to 567 and so on. To see if this is geometric, I'm going to take 1,701 and divide it by 567. And that gives us 3. I'm going to take 567 and divide that by 3 to make sure we get 189. And it does. It works. So divide by 3. And 189 divided by 3 is equal to 63. 63 divided by 3 is equal to 21. And 21 divided by 3 is equal to 7. So our next pattern, the next in the pattern would be 21 and 7. And it would be geometric because there's a consistent multiplication and division happening here. Here's another example about inductive and deductive reasoning. It is asking us to find inductive reasoning this time, an example of inductive reasoning. Here, so the first one asks, it tells, the corner bakery has a sale on muffins every Saturday. Since tomorrow is Saturday, muffins will be on sale. Do you think that this is deductive or inductive? I think that it's deductive because it is going from a general that every Saturday, they have a sale. However, then it goes to specific, which is tomorrow, Saturday, muffins will be on sale. So this would be deductive. We're not looking for deductive. A small karate dojo offers free classes to college students every July. So this July, the karate dojo will offer free classes to college students. So it goes from a general to a specific. This July, it goes from every July to this July. So this is also deductive. We don't want this. I have to be to work by 8 a.m. and the commute from my house to work is usually 10 minutes each day. So I will be on time to work if I leave at 7:45 a.m. today. This goes from a general to a specific. So it is also deductive. This one says, Kara should catch 40 out of 75 targets in the next 5 games since she caught 80 out of 15 targets in the first game. This is going from a specific to a general, which is inductive reasoning. This is the answer that we want. Hopefully that makes sense. It takes a little bit of time getting used to. This one is another sequence question. At first glance, you can kind of assume that it's probably not going to be geometric. We can think that maybe it's either arithmetic or neither. If it was geometric, it would probably be increasing at a different rate. That doesn't mean it is impossible for it to be geometric. It just seems like arithmetic is our better option here. We know from 12 to 16, it's plus 4. From 16 to 21, it's plus 5. From 21 to 27, it's plus 6. And that stands to reason that the next one will be plus 7. So 27 plus 7 is going to give us 34. And then 34 plus 8 is going to give us 42. So our next ones are 34, 42. And it is not arithmetic because it is not increasing at a consistent rate. It is not geometric because it is not being added, multiplied, or divided. It is going to be neither. And yeah, that covers some of the content for 1.1. If you have any more questions, please just let me know and I will answer them as soon as I can. I know it was a little more complicated today. Have a good one.